what we're looking at today is postulates and diagrams. Postulates and diagrams. And we'll look at some of the postulates, and it's going to be, a lot of what we're doing today is kind of how they work and what they do with them and how we can visualize them or see them or draw them and use them. Now, this first one, we have two postulates. Let me get a highlighter. The two-point postulate states through points A and B, there's exactly one line. The two-point postulate, there's some stuff right here. Through any 2 points, there exists exactly one line. Through any 2 points, there exists exactly one line. Through any 2 points, there exists exactly one line. Well, we know that, yes? Because when we went over lines, we talked about the fact that through any 2 points, there exists one line. Well, we can say the opposite, can't we? Through any line, a line contains at least 2 points. Through any 2 points exists exactly one line, and a line contains at least 2 points. And this stuff here is building up basic geometry. When they first were proving stuff in geometry, they started at the basics. We have a point, 2 points make a straight line. If we have a straight line, we have at least 2 points. Line intersection postulate. If two lines intersect, their intersection is exactly 1 point. If two lines intersect, they intersect at exactly 1 point. Because do lines curve? Then it wouldn't be a straight line and we wouldn't be Euclidean, but straight lines don't curve. So there's only, when they only intersect once, they're not going to come back. So our line intersection postulate states that if two lines intersect, they intersect at 1 point. They intersect at 1 point. I will have a reference sheet for y'all that has all these postulates. They're also in the back of the digital textbook. So we have these two here. You ready for what's next? Anybody still copying? Yes? Okay. And that's what we're looking at here, is we're looking at some of this stuff here. Now you can, for the first one, if you want to circle and kind of reference what's being talked about, because there's those two things there. The first half that I did highlight through points A and B, there exists exactly one line. That's talking about our 2 point postulate. The second half, line L contains at least 2 points. That is talking about our line point postulate. So 2 point postulate saying through any 2 points we have a line. Line point is saying through any line contains at least 2 points. So we kind of have 2 and 1 on that one. You should read that. Now we have these here. 3 point postulate. Through any point 3 non-collinear points, there exists one plane. Well, we did that, yes? Because when we talked about planes, we need 3 points that aren't on the same line to name a plane. So through any 3 points, there exists exactly one plane. Through any 3 points, there exists exactly one plane. 3 point postulate. What kind of means the plane point postulate is that any plane contains at least 3 points. Through any 3 non-collinear points, there exists exactly one plane. A plane contains at least 3 points, 3 non-collinear points. erase the last two. If 2 points lie in a plane, then the line containing those points also lies in the plane. If 2 planes intersect, their intersection is a line. The sheet I'm passing out here has these on them. So if you have trouble reading the board and want to write them down, they're on here. All right, guys. So let's look at example 1. Let's look at example 1. The directions for this state the postulate illustrated by the diagram. If we have 2 lines that cross, then it kind of highlights a point, yes? So what is that saying? If 2 lines intersect, then they intersect at a point. So what's the postulate called? Line intersection postulate. So this here is the line intersection postulate. Because the line intersection postulate states if 2 lines cross, then they cross at exactly 1 point. If 2 lines intersect, then they intersect at a point. And that's our line intersection postulate. So if this was a question on the homework, that's all we have to say. It's the line intersection postulate. That's what it's describing here. Questions on this one? So we have 2 planes, then I kind of highlighted a line where they cross. So what is this here? This plane. I think you got it right the first time. They intersect at a line, so it's plane intersection postulate. Plane intersection postulate. If 2 planes intersect, then their intersection is a line. We can just say plane intersection postulate. The second half of that is just saying what it is, explaining it. So it's the plane intersection postulate, because if 2 planes intersect, they intersect at a line. State the postulate illustrated by the diagram. So if, we have a line, then, because 2-point postulate says what? So for any 2 points, there exists exactly 1 line. Well, we started off with a line, didn't we? Yes. So it's the other one, the line point postulate. Because it says if there's a line, then there are 2 points. Now, if it had been the other way around, if 2 points, then there exists a line, then it would be 2-point postulate. So if this was flipped, it would be 2-point postulate. But this here is line point ATE postulate. So there's a slight difference between those two. There's one starts with a line and then we have 2 points, line point. One starts with 2 points, then we get a line. Questions on this here? We're just kind of identifying which postulate, yes? What would we say with this one here? Yes, this is plane point. Almost, actually. Mm-hmm. 3-point postulate. Because plane point postulate says if there exists a plane, or any plane, there exists at least 3 points. 3-point postulate says through any 3 point, there exists exactly one plane. So it's easy to get those two flipped. It's easy to get those two flipped. So it all depends on what we're starting with. Here we're starting with 3 points, and then it says that there's a plane, so we do 3-point postulate. If it had started with a plane and then gave us 3 points, then it's plane point. Use the diagram to write examples of plane point postulate and plane line postulate. Plane point postulate. So what does plane point postulate say? If there exists a plane, in any plane there exists, so 3 points that aren't on the line. So using this here, because we have a plane, plane P, and we have points B, A, and C on that plane, yes? That's it. That's kind of like what we did in chapter 1, isn't it? Name 3 points on the plane. We just named it differently. Plane, line, postulate. That's it. Because if 2 points are in a plane, then the line also is included in the plane. That's it. Anybody's mind blown yet? Okay. Which postulate allows you to say the intersection of plane P and plane Q is a line? Oh, writing tool works. Plane intersection plane intersection postulate, because the plane intersection postulate states that if any 2 planes intersect, they intersect at a line. And that line here would be line M, little m, line little m. That's it. Any questions on any of this here? We good so far? This one?
Wouldn't that like contain line into?
Line N or line M. Mm-hmm. Because line M is contained in both planes, so we could use it for either plane. And line N would work for either plane. Either one of those would work. As long as the line wasn't coming out of the plane, then it would work. So we have here 2 point, line intersection. Let's start off with 2 point, 2P, 2 point. 2 point postulate stated what? Through points there exists. Yep, through A and B exists AB. And you're probably not going to have to write all that out. It's probably just saying line AB is an example of 2 point postulate, because through points A and B there exists line AB. Because through any 2 points there exists a line. Any questions on 2 point? We good with 2 point? Okay, I'm going to erase that so I have space. LP, line point. Kind of what we just did, isn't it? BA contains points B and A. Nope, I'm just going to keep writing. Contains points A and B. Because our line point's pretty much saying through line AB, or ABBA, contains points A and B. The line contains 2 points. And that brings us to the last one, line intersection. We good for me to erase this? Anybody else still copying? Line intersection. Line M and N intersect at what? Yes. Point A. They intersect at point A. They intersect at point A. I kind of impressed myself. I thought I made that A into a triangle. I thought I drew the line a little too low. Any questions on 2 point, line point, or line intersection? We good with these postulates here? Good so far? Because a lot of what we're doing here is what? Just taking the postulates and applying them, yes? Understanding the postulates and applying them. Sketch a diagram showing line VT intersecting segment PQ at point W. Okay. If you've noticed so far, anything where it said kind of draw, did you have to draw it on the homework? Did you have to draw anything in the homework? No, you're selecting which one matches, yes? So, okay. So it's really identifying and looking to see what is it describing. So the first thing it tells me what is showing, so I have a line TV, yes? Okay. Line. T. V, yes? I need a line and I need 2 points. Because that's what it told me. Intersects. Okay. Line segment PQ. Because we knew it was a line segment because PQ above it had a line segment that just described it, yes? At point W. So where's point W? Where they intersect, yes? Have we drawn everything it described? Not quite. Is congruent so that they're congruent. Wait, did I draw these anywhere close to congruent? No. What did I say pretty much first week of school? Figures lie. Y'all been seeing that? The segments lie, the figures lie. Y'all took the chapter 1 test. Did any of the lines look like they should have? They were close, but sometimes they were off. Ready for this? Hey, they're congruent. Because again, those little dashes on lines mean that the segments are congruent. That's it. That's all we have to do there. We drew a line, TV, because that's what it said. It intersected PQ, segment PQ at point W. We did that. And we identified it so that TW and VW are congruent. That's it. Let's see what this says. If the given information states that PW and QW are congruent, how can you indicate that in the diagram? we can put 2. We would put 2. Now, the reason I would put 2 is because are they congruent to TW or VW? Well, no, we don't have anything that says that they're going to be congruent to these 2 measures here. So we add another line because the number of those little marks are congruent to the same number of marks. So any of them that have 1 mark are congruent to each other. Any that have 2 are congruent to each other. So 3, 4, 5 going on up. So that way I can use these marks multiple times to show that different things are congruent to each other in the same figure. Sketch a diagram showing ray R, or ray Vx intersecting UW at V, so that Vx is perpendicular to UW. So we have a ray. I'm going to draw it straight up. V, some point up here is W. Intersecting line UW at V. Oh, I was wondering why that made no sense. This needs to be X. U, UW. Huh? This here? Yeah, it's still V. So that X, so Vx, ray Vx is perpendicular to UW, and U, V, and W are collinear. So we have UVW collinear. Perpendicular. 2 things are perpendicular if they make a, what kind of angle? 90 degrees. They're perpendicular if they make a right angle. I'm going to draw my little box, because my little box makes it right, makes it a right angle. So that's all we have to add to show that they are right. They have a right angle. Huh? Yeah, we can do it on either side, but we only need 1. We only need 1, because if it's a straight line, the 2 angles add together to be 180. As soon as we know that one is 90, the other has to be 90 by definition. Any questions on this here? That leads us to another postulate. A line is a line perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So a line is perpendicular to the plane if it's completely perpendicular to any other line we can draw on that plane. Any other line on that plane. In a diagram, a line is perpendicular to a plane must be marked with a right angle symbol as shown. It did 2, you can do 1, but it has to be right. It has to make a right angle. Has to make a right angle. Okay. Number 4, example 4. Looking at this here, they're kind of close together, but luckily you guys have more than enough space to write. I'm going to run out of room. Which of the following statements cannot be assumed from the diagram? So really, we're going to go through and say either yes, they can be assumed, or no, they can't. We got one or the other. Because again, in this class, if we have a postulate, so the postulates we just went over in today, so kind of 2. So looking at that sheet from 3.1 on, so any of the ones that start with 3 point something or 4 point something or 10, or any of the things that we didn't cover on the sheet, can we assume those? No, we haven't proven those yet. But looking at this here, points A, B, and F are collinear. So in this diagram, where is A, B, and F? A, B, F. Are they collinear? The little dashes just means we can't see it. It's just behind the plane. So what do you guys say? I'd say yes, because they do make a straight line, don't they? Yes, we can't assume that. AB is perpendicular to line S. AB is oh, sorry, I skipped one. Points EB and D are collinear. Can we say EB and D are collinear? No, E's over here off by himself. Yes? So this is, no, we can't assume that. Okay, now we got to it. Plane A, or line AB and plane S are perpendicular. Do we have a right angle marker
Yes.
with that plane? Yes, don't we? Right here, it's perpendicular, so yes, we can assume that. CD is perpendicular to plane T. What do you think? What do you think, Caleb? So perpendicular means right angle, yes? They make a 90-degree angle. So where's CD? Here. Plane T? Is there anything that states that they are making a right angle? The line CD in this plane. Well, they don't tell us much at their intersection, do they? Because if we had this little box, then yeah, they would. But do we have it? So can we say that they're perpendicular? No. Because unless it states it, or we have a theorem that tells us it, we can't say it's true, and we don't have it there. Now that brings us to the last one. Line AF intersects BC at point B. So let's see where AF are. AF is going straight up and down, yes? BC. Did they intersect at point B?
Yes.
So can we assume it? Yes. So we have two more. Number 6. Can you assume that plane S intersects plane T at BC? Can we assume that? So plane T and plane S intersect on this line here, yes? And what is that line? It contains 2 points that are B and, so this is, because that line, where those two planes intersect is plane BC. Because line BC is this line here, and that is exactly where they cross. If it had talked about AB, then it wouldn't, because that's not where the two planes intersect. Questions on that one there? Any questions on that one there? Really, when we're looking at a line, if it can, both planes contain the 2 points, then it would intersect. If both planes contain the 2 points, then it would intersect. Explain how you know that AB and BC are perpendicular. Explain how you know AB and BC are perpendicular. Right, it's saying AB is perpendicular to this plane, yes? Now, the last postulate that we kind of covered, or last statement we covered, a line is perpendicular to a plane if and only if, what? It is perpendicular to every line on that plane. So exactly right. So because it's perpendicular to the plane, it is perpendicular to the plane, so it's also perpendicular to every line on it. You can put it, you don't have to put in exactly that wording, but just kind of get the gist of it. It's perpendicular to the plane because it's perpendicular to the plane, need a line. So it's perpendicular to everything else on that plane, every other line on that plane. And if we were doing a proof of this, we would actually need a little bit more rigorous kind of explanation, but this will work for us. Then we ran out of notes, and that's it. That's all we're doing here. That's it. That's it for today.